This is the 3D printed 163 Comet. Easy to print, easy to build, lots of fun to fly, and the files are available for free. And at the end of the video there will be tips for printing and building, so make sure you stick till the end. It all started with this slingshot that I made to get the TBS Mojito in the air. This evil claw is bent from steel, welded together, 2 fitness bands attached to it. It's like 3 meters of rubber, 2 meters of string, and then this launch thingy, which is in the files. You need this for the plane. When I built this launch slingshot, I made some little toy gliders and they went in the air like a rocket. And that's where I got the idea to make this Messerschmitt 163 Comet thing, because the flight pattern is really similar. Another thing that I wanted to try with this plane is to make it out of TPU. Here are some of the test parts. TPU is a really tough material, really hard to destroy. Bends back really easily, and even after this much destruction, basically good to use again. Of course it comes with a few disadvantages. It's not very stiff, airplanes must be stiff. This was the first test part. I made this with my usual 3D printing techniques with custom internal structure. But for TPU this isn't really practical, as you can see bends much too easy. Then I went with gyroid infill, works really good for our TPU. And there's also a few custom reinforcements in there. Here's the wing part with the elevon directly attached. And as you can see, elevon is super bendy, that's not good. So in the final design, elevons are made from PLA. Okay, let's take a look at the plane. So in order to get the wings pretty stiff, I placed the usual 1mm carbon fiber rods on the upper surface of the wing and the lower surface of the wing. Few drops of CA glue, pretty strong. And as you can see here, elevons from PLA. Canopy slides off like this. We've got receiver and a battery. This one just uses 2S batteries for the servos. The launch hook slides in like this. Yeah, so that's how a launch works. Bottom fin is pretty flexible, so you've got to watch out when storing it. See how it bends. This is another one that I made. Almost the same parts, but this one printed from lightweight PLA. There's also an alternative rear fuselage with motor mount. The hole in the back is big enough to fit some standard size rocket engine, model rocket engine. Of course 3D printed, so watch out with the heat. Recommended motors would be like 1806 on 3S with a 5-inch prop, something like that. And then you also need 2 standard 9-gram servos, nothing special. And I've also got some different canopies. In the files there's this one. You can put the Insta360 Go 2 or the Calyx Peanut camera in there. It goes on like this. Or there's this one, you can put FPV cameras on there if you want. Okay, so the way it flies, launching it is very much fun. Doesn't give you much flight time, but definitely an eye catcher at every airfield. I think everyone should make one of these. When launching, remember to launch it at a little bit of an angle, kind of like this. Also pull the elevator like quarter to half, otherwise the launch might fail, that's very important. Then after it disengages, it will go straight up, turning all the kinetic energy into altitude energy. TPU plane is pretty heavy, 360 grams without a battery, and this one's like 220 without battery. They use like 2S 1000 mAh batteries, so that's like 100 grams of batteries for them. 700mm wingspan, 430mm length, around 500 gram all up weight, 250 gram from lightweight PLA. If you're using motor with lightweight PLA, 400 grams. TPU thing is pretty fast. Got to watch out on landings. If you want to fly the fast EDF jets, make one of these, practice landings. It's really good for practicing landings. You really have to watch your landing pattern. Always watch your speed and your angle of attack. Landing this on a spot is pretty tricky, but if you can land this, you can land basically every EDF jet. We also tried arrow tow. Arrow tow works. You need a tow plane size of E-flite timber roughly, but be aware, this one does not have a tow release, so you need a tow plane with a reliable tow release, and when the rope will be gone, so maybe place some high visibility parachute on your rope. Okay, so you don't really get that much flight time. If you get a really good launch, you can get about 30 seconds of glide time if you're stretching it. Or if you want to do aerobatics, maybe one loop and one roll in one flight. This thing has definitely enough kinetic energy to make a fast low pass and then still do a spot landing. But yeah, overall really good for practicing energy management in like gliders, jets, anything fast. This is not really like a sophisticated RC airplane, it's more of a stupid little toy, but it's very much fun. Okay, now some printing and building tips. Before you start printing, make sure you select the right parts to print, select the right canopy and also the right fuselage. But because of the cable channel in this part, if you print this from TPU, it will be a lot heavier than this version. So most important when selecting the parts are the wings. As I said, TPU ailerons are so flexible, they are not really usable. So there are two different styles of wing. You've got this one, which has the ailerons directly attached for printing from lightweight PLA or normal PLA, then it's just the living hinge, like this. Or these with separate ailerons, here you print the wing part from TPU, aileron from standard PLA, glue it on top, so done. All the parts, no matter the material, are printed with one outer shell. Then I use like 2 bottom layers, 2 top layers. And when printing DPU, infill varies. Here from lightweight PLA I've got like 3% infill, 4% infill in all the parts. For the TPU it's 5% infill on all the wing parts, 4% infill in the front section of the fuselage and 3% infill in the rear section. Make sure your bed adhesion is good. If it's not good, then use a brim. Make sure to print the TPU reasonably slow. Remove all the stringing before putting the parts together. And here you can see the centerpiece, the spar box. You definitely want to print this from normal PLA. Then you insert the 1mm carbon fiber strips in the spar box. You need 2 times about 500mm of length in the front and 2 times about 650mm in the rear. After you've glued this to the center of the fuselage one, you can thread on the wings. Just slide it in. Here's the part you print from normal PLA, it's called the launch reinforcement. Then you also glue down this canopy clip thing, so that the canopy slides on. Of course, remove all the build plate adhesion helpers. Of course, center the servos before putting them in. Servo arm goes like 90 degrees up. Then just install whatever linkage you want. If you want to, you can reinforce the rear with carbon fiber strips. CG is 88mm behind this leading edge point, and a visual identifier for this is this servo channel. You see the servo channel leaves a little mark on the outer surface, and you want to go right to this point, here, and that's where your CG is. Of course, you should always use RC planes responsibly, but with this one it's really important, never launch this in the direction of people. For its size, it can cause a lot of damage. And that's basically it. Check the link in the description to get the files. Files are free. Also, if you need help, check out the RC groups thread. Right, have fun building and see ya.